Okay, so in the commercial aspects, there's kind of three core requirements that one would have, right? One, as we just talked about, you would need to provide an alternative to the typical instance-based licensing for this to actually make sense. The second is that you need what I would call bidirectional elasticity. Most vendors talk about scale out and scale up, but what about scale in and scale down when your usage requirements go away or minimize? The third piece would then be to have native controls to keep a handle on costs, because if you just let all of your business units in IT go hog wild and deploy what they want, things could get out of control very quickly. This is basically the model that we've created with our per app metered licensing approach. I'll demonstrate this visually in a moment. But the way that this model works is basically to say, instead of you being charged or on the hook for the capacity that you deploy, you're going to just be charged or on the hook for what you actually use. And so if a customer has a requirement for 5 load balancers during one quarter and 50 load balancers in another quarter, there's no inherent penalty for that. We're just going to look at the utilization that their products have actually done, and based on that, they'll get charged. You can now kind of walk this back and connect this to what we talked about earlier, the concept of needing to over-provision years in advance and hope that you got it right. Or new applications and services pop up and you've got to go back to finance in order to go through the red tape to get new systems put in the infrastructure. The point of this is to unfetter customers from that. There's also the concept of the cost controls, which we talked about. You would want to make sure that this doesn't get out of hand. The normal approach for deploying a load balancer is that you put it in an HA mode in many cases, meaning that it has at least one, if not more, partners that are participating together. Well, fairly, you would only get charged for that as a single unit. The scenario would be that if you had a 2-node cluster, as an example, the first load balancer does 1 gig of throughput. You then fail that over to the second load balancer, which does a gig. Would you get charged 2 gigs or 1 gig? Well, you should just get charged 1 gig because it's one logical unit. There will also be the ability to throttle things so that you can control how much throughput the devices can actually do. This is the framework of what we've built and what we called our per app metered licensing approach for load balancing. Just to show visually how it looks, imagine a customer has 3 load balancers over the course of 1 month. Load balancer 1 has a peak over that month of 8 gigs, the second 5 gigs, and the third 2 gigs. What we're going to do is we're going to look over that 30-day cycle, and I'm going to look at the highest peak that each of those devices did. Those peaks then get combined and added up. I then leverage that to develop an invoice for the customer. Now, a couple questions, again, that we've seen often when we talk to customers. The first question is, well, what if I have errant peaks because of DDoS attacks or something like that? We apply a 95th percentile rule, similar to the way service providers do, to kind of smooth that out. So if you were to have DDoS attacks, there was some unexpected traffic flows, that basically gets tossed away. The second question we often get is, why did we go with the model of looking and measuring peaks as opposed to total throughput, right? Because when you think about networks, you often think about what's the total amount of data that has traversed some part of it. The challenge with that here is that you don't typically plan your load balancing ecosystem that way. Again, if we go back, I think about over some period of time, what's the max capacity that this load balancer environment is going to have to handle, and that's how I plan. So we built a metering model that didn't have to make customers think too hard, right? You still think in the concept of what's the max capacity that this aggregate infrastructure is going to require. Based on that, we then put you into different bands and the customer gets invoiced. And so now some of those constraints that we talked about, the per instance licensing approach, the potential of cost and getting out of control gets addressed. Any questions, comments around this? Anything not clear?
Are you also able to tie this peak information back to the actual application so the customers have some insight on where am I starting to get dinged in terms of what applications are actually starting to cost me money?
Absolutely. So that kind of builds here. So we talked about those 3 components. The way that this works in practice is that the customer will have Kemp 360 Central. That provides them a console where they get all that visibility. So they can generate on-demand reports. There's the kind of pre-canned monthly reports that get generated, and they can tie the usage and the peaks to individual devices, individual services themselves. So say I'm a service provider and I have many different customers, I can see which customers it is that's actually impacting my total invoice. If I want to input some type of throttling, then I can do that as well.
And are you targeting this primarily at service providers, or is this also for enterprise?
Both service providers and enterprise. So we've got a case study we'll talk about at the end, but it's kind of jump ahead with ASOS, in fact, who's a very large e-tailer. And they had some interesting requirements. They have obviously seasonality. They were expanding into Azure, bringing some DevOps into their ecosystem, and this fit perfectly with them. But equally, there's a number of service providers that we work with as well: Steadfast, Loom, Hosting.com, CenturyLink as well. So there's certainly a mix here of models. Any other questions? Okay, great. So we all agree. Moving on. So that's kind of the commercial bit. We didn't want to spend too much time there, but wanted to give some insights. The second is the technical feasibility, because again, if you are going to have many instances that are running across this infrastructure, you need a way to get consistency. You need a way to manage it all. You need a way to define desired state, make sure that that's consistently applied. And so we'll talk about that and we'll actually demonstrate what that looks like in a minute or two. Just in terms of expectations, these demos are recorded. Happy to do some one-on-one time later if you want to dig down into the products and all the menus. We only have an hour, and I didn't want to test the live demo guides, so they are recorded. But if you think about the technical bits, we kind of dimension it across the different parts of the life cycle, right? With day zero operations really being all about how, in a frictionless way, do I do assessment, start looking at my requirements, and get an understanding of what's happening. We've done a number of things in that space. For one, we have a freemium product targeted at DevOps, as an example, that allows customers to just go and test and see how our products can work in their infrastructure. The other piece that we've done is enabled a set of tools that allows a customer to build their confidence that we can actually meet their requirements. Just a small anecdote. Many are probably familiar with F5 networks. They're basically the Cisco in the load balancing space. And so normally when we engage with a customer, they're familiar with F5. And so we'll ask the question, I use F5 to do that. Can you do this as well? F5 happens to have a language called iRules, which is a very powerful scripting language for traffic manipulation and configuration manipulation. And you may have a second or third generation administrator that's inherited an F5 ecosystem, and they may have hundreds of iRules, and they're scared because they don't know whether or not changing those iRules is going to have an impact, and they may not have clarity about which ones are actually being used. We've built some tooling around that as an example that allows us to, for example, look at an F5 configuration, look at a Cisco ACE configuration, still pretty popular in the finance industry, get an understanding of what rules are in use, as well as how you would map that over to a Kemp ecosystem so that you can actually test it before you move over to this model. So that's just some of the things that we do around day zero, making it easy to analyze your environment. If you were to drop in 360 Central, we can also start to absorb the configuration information about what your load balancer ecosystem looks like today, even if you're not using Kemp. So we've extended capabilities to support HA Proxy and Nginx, which you may have some small DevOps groups perhaps using. We can also start to absorb information from AWS Elastic Load Balancer. With Shadow IT, there's likely some of that going on in your environment as well. And F5 would be one of the other commercial products that support it. So with this kind of set of tooling, a customer can confidently assess where they are now before they start evaluating whether or not this per-app model makes sense for them. If you move on to kind of day one operations.
So just real quick before we move on, if I have two F5 load balancers, I'm interested in Kemp, how automated is that process if I want to move over? Is it going to just analyze the rules that I have, or is it actually going to translate them for me and write them into the Kemp?
Some of them will. Some of them are going to need to be assisted with our pro services because there's just some very complex things. When we get to looking at the load balancer interface, there's dozens and dozens of settings. So I will say there's not 100% coverage, For some of them, there is automation. An example I can remember was a customer who, there was some security vulnerability in iPhone, and they just wanted to block a specific iOS version. And they had a set of F5i rules to do that. With our tooling, we were able to then migrate that and translate to what we call our content switching rules. But there's not 100% coverage yet. Probably never will be, right? But we want to engage with the customer because that provides us an opportunity to address if everything they're doing is actually even required or not. And so in that kind of pre-sales engagement, we can start to evaluate, is there an opportunity for simplification?
Gotcha.
Okay. So day one operations, we're now getting into the next step. You're perhaps getting past UAT, you're getting past your POCs, you're starting to move closer to production, maybe introducing some production. The focus there, and again through this load balancer lens, is how do I simplify configuration? How do I ensure that I'm getting consistency in what's getting deployed in the ecosystem? Day two operations, you're then on to the next step. I'm in full-blown production. I'm getting to scale. This is the point where I'm now getting introduced to the problems of scale, right? How do I keep the lights on? How do I address maintenance? And as well, how do I start to optimize my ecosystem as well? And so we've got a couple of things along this kind of journey that helps customers to address these different parts of the life cycle. And we're going to talk about these by way of demonstration. So the first demo we're going to look at, we're going to be starting inside of Kemp 360 Central, and we're going to be looking at some automation capabilities that we've integrated to help with day one operations. We recognize that different customers are at different parts along the automation maturity path. Right? There are some customers that have kind of built their own ecosystem with the Lego bricks and parts that are out there. Some customers rely more on the vendor. And to address those customers that rely more on the vendor, we've built these capabilities. And so what we'll be looking at is the creation of a load balancer profile and the automated deployment of that profile into a VMware infrastructure in this particular case. So let me get
your instance is running on VMware.
In this case, the demo is in VMware, exactly.
And you support all hypervisors.
We support all hypervisors. Okay, so we're starting here in our VMware ecosystem, and I'm logging into our central instance. Just not going to spend too much time here, but here instead of central, this is just a view you get. It's a dashboard. It's giving me some insights about what's going on in my ecosystem, overall health. What we're particularly interested in for this demo, though, is down in the configuration management and automation section. And here we are here. So there's kind of two parts to this puzzle. One is the target environment, and the other part is the load balancer profile. The target environment is basically the definition of where I'm going to be deploying the instance into. And the load balancer profile is all of the various configuration pieces about that load balancer that I'm deploying. We're showing it to you through the UI, just because it's more demonstrable. Of course, this is also available through the API as well. If I go to target environments, here, as I mentioned, I happen to be deploying into a vCenter ecosystem. And so here you have the credentials for that environment because I'm going to log in and it actually leverage the API to automatically get that instance up and running. So the app admin who's responsible for this app service, responsible for the load balancer, assuming he or she has the rights or is working with the right group, isn't going to need to come here and then separately go into the VMware ecosystem. Assuming that ecosystem is set up properly, from this single place, they can actually get this new instance up and running end to end. Now canceling out that, we'll head over to load balancer profiles. And here we'll kind of walk you through the steps of what's involved in actually setting up the load balancer in the first place. So we're going to give this profile a name. I think I just call it NFD demo. You then get to define whether or not this is going to be a standalone or an HA pair, which we talked about earlier. And so if I were to define an HA pair at the end of the instantiation, I'd have at least two instances that are behaving as part of a pair. They're already paired, their configurations are synced, and so forth. In this particular case, we're going to just do a standalone, give it an IP address, give it a gateway, and give it a port on which I'm going to access the UI. The last piece, which I think is interesting as well, is we talk a lot about frictionless, right? How do I make it easy for a customer to get up and running without having to go to finance, come back to the vendor, and so forth. With the per app licensing model, the customer basically gets a pool of licenses that they're able to access. It could be virtually infinite, or it could have a cap to it. But once you're set up with that, each time you need to deploy a new instance, it just extracts it from the pool. And so that's what this last section here is. I could have a more complex licensing agreement with Kemp where I have different options. In this case, I just have one. And so once I go through the process, when the instance comes up, it's going to be fully licensed and working and ready to go and supported. So the next step is that an emulator will get launched, and this emulator is where I'm going to be able to define all of the settings that I want to for the load balancer. So the emulator looks exactly the same way that the Loadmaster UI looks, but it's just an emulation. And in there I can create services, I can import SSL certificates, set up VLANs, VXLAN, anything that I need to do. This profile is then set for multi-use as I go forward. I will say I'm taking you the kind of scenic route just so you can see it. This is also going to have in our one of our releases in the next couple months what we call a quick mode, where a lot of these deeper level settings are abstracted. So the customer only has to do one or two things, but just wanted to show you the full board of what's involved here. So the emulator's launching.
In your HA mode,
Yep.
is that strictly active-passive, or do you have any type of mode where it's like an active-active?
We have clustering as well,
Yeah.
where you can do a multi-node clustering. That's not currently supported in this particular automated deployment flow, but it's on the roadmap to be there soon. But as far as our products in general, yes, you can
do
set
it,
up
you
a
just
cluster.
can't do it through this
You
provisioning
can't do it through this
process.
provisioning process yet, but there is clustering available as well in the products. And all right, so now I'll launch the emulator, and what you'll see is I'll get an interface that looks like our load balancer. Self-signed cert, obviously. I've set the password as I was going through the process of entering the IP address and so forth, so I'll use that password to log in. And once I get in, I can do anything that I could do on a real live running load balancer as well, as I mentioned. In this particular case, I'm just going to publish or create an application virtual service. A virtual service, or a VIP, in the concept of load balancers is basically how an application gets represented. It's just the IP address, the virtual IP address that customers connect to for the app, pointing to back-end real servers or VMs. So I'm going to create one of those now.
So you first launched the emulator, which is a VM.
It's a VM that's running inside of the 360 central instance, exactly.
And then on top of that VM, now you're going to configure your VIPs.
I'm doing the configuration, then this configuration is going to be used to push an image into VMware.
Okay.
So this is just giving me a model that allows me to do the configuration once so that I can then store that and reuse it for deployment elsewhere. And like I said, we have on the roadmap what we call our quick or guided mode, which the customer can go and do all these settings if they want and have the requirement for, but we'll make some assumptions on best practices and just abstract to a handful of settings for the customers to input. And so I'm going to create that virtual service. Just wanted to point out real quick here, as we were talking about earlier, there's many different settings around WAF and security and identification that can be configured. And this is to your question earlier, why everything's not 100% automated when it comes to migrations just yet, but we're on that path towards there. In this case, we're just setting up a simple virtual service that just has two back-end real servers behind it to send traffic to on port 80. So if this demo works, the way that it will work is at the end, I wind up with a new virtual load balancer stood up inside of VMware that has a virtual service on it with two real servers behind it that's ready to accept traffic. We'll just skip ahead a little bit here. Right, so now once you're done, you exit out of the emulator. The Kemp 360 Central recognizes that you've exited it. You then move along next. Give it a second to finish registering. Okay. And the next step, I get an option. And that option is whether or not I want to do an automated deployment, which is what I've been talking about, where I'm going to directly connect into my hypervisor API and push the configuration down, or if I want to do a manual deployment. And a manual deployment means basically that I'll get a disk image out of the back end of it, and I can then just stand that up later. When I stand it up, it automatically is licensed, and it talks back to the central instance to register itself into management. The use case for that may be I'm just not ready to stand it up yet. It may be that I have to work with another team before it comes online, or what have you. In our case, we're going to do the automated deployment, though. And in a second, once we start that, you'll see the target profile that we looked at earlier start to come into play. And so here, you get to pick what's the environment that I'm going to push this into. We're picking my vCenter lab that we have. Once it logs in, it then enumerates resource pools. It enumerates the data stores, and it enumerates the network options that are available inside of that vCenter ecosystem. I'm going to select the ones that I need for here and also set it to power on after deployment. So the point here is that from this workflow, you wind up with a load balancer that's ready to front end of the application service right through this flow here. So next step is to switch over to vCenter, because that's where we should see the magic happening now. Central's done its job. It's sending off its API calls. It's pushing the image into the VMware infrastructure. And we should see some stuff start to happen over here on vSphere.
And as part of this process, does it automatically create the anti-affinity rules to ensure, if it's a cluster, that they're on separate hosts?
It does not do that today,
Okay.
but that's something that we are looking into as well, right? So in this case, we see the OVF template getting deployed. We see some library entries, and there it is. If we look over here, NFD demo Feb 13. It's launching. We'll go into the console now. And here, just the normal load balancer boot sequence that you would see. At the end of this, we should get an IP address. It should be 10.10.10.247, because that's what we set up earlier. If it's not, there's a problem. But it should show me that the UI IP address is 10.10.10.247. Let's see what happens here.
At what point does it make sense to go from a hardware traditional load balancer to a virtual load balancer, where you're bringing that load into your virtual environment, your VMware? At what point does that trade-off make sense?
What point does it make sense to go hardware versus virtual, is the question?
No, from a traditional old hardware where you're doing your SSL offload on these appliances and bringing that into your virtual environment.
It's going to just depend. It's going to depend on a number of factors. I'd say one factor is just the operating model you as an organization have. There still are organizations that aren't ready to virtualize network functions yet, right? So if that's the case, that's kind of a non-starter. There may be some cases where you're getting up to kind of web scale type capacity requirements where not having the SSL acceleration that you get in hardware may also be a challenge. So if that's the case, and you'd have to build a gigantic hardware VMware host to make it work, then from just a costing perspective, it may make sense for hardware as well. But in general, if you're moving to a cloud operating model inside of your infrastructure, you're starting to play with DevOps approaches, you're bringing containers, you're doing any of these type of things, virtualization oftentimes is going to make sense, because you are likely to end up with smaller pods of applications that don't have those requirements. So it's really that evaluation. It's not a clear black and white that once you get to this capacity or have this number of applications, virtual makes more sense. But to give an example, there was a customer we were working with in Europe, a large bank, and they were in the process of doing just that, going to an infrastructure as code model, trying to start to introduce some microservices, and the inflexibility that you just get with hardware just didn't make sense. The fact that if they were going to bring on or migrate new application services, it meant going and working with finance, getting another hardware system, going through the process and the red tape of getting that approved to go on the network. It was just going to get in the way of the speed at which they were trying to move. So it's not kind of a black and white answer, but I would say those are the kind of factors that have to be considered.
Understand.
Okay. So this is deployed, 10.10.10.247, as we said earlier. We'll go ahead and log into that. And we should see that we have a live load balancer instance. If we go to the virtual services, there's the virtual service that I set up earlier. I set it up on the same IP address, just using a different port. The UI port is 8443. The interface for the VIP is port 80. And I should now actually be able to access that virtual service. It's just a simple IIS service. And if I go there, boom, there we have it. Right, so this is just an example of how you can automate the process of getting new instances up and running, which is a key requirement for the per app model. Because if you're going to this model where you're going to have dozens, perhaps even hundreds of instances, if you had to go to each one of them, configure them independently, get them set up, it would get very challenging, and you wouldn't have the agility that you're looking for.
If you want to add another load balancing port, like another service, then how do you do that?
You can do a number of ways. You can do it through Central. So I can just go to Central and I can update it manually. I can update the configuration profile. There's a number of models that you can do it locally on the load balancer as well. So you have a couple of different paths in to update things.
So you can update it locally on the load balancer.
Yeah, you can update locally on the load balancer through the API from Central, which was our starting point.
Right. So Central then doesn't remain like as a source of truth then. Like it's really just the automation on the front end to get it deployed. Once it's there, then it's like an independent instance.
Not today. The next time we're doing a network field day, I'll be demonstrating to you how we do drift control as an example and ensure that the configuration stays as what you want it. This was just really the first step in. But what you're talking about is absolutely the roadmap direction of this feature set.
The other thing I noticed there, right? So I mean, obviously we're setting up a new instance with a new service.
Yep.
There was a lot of point, click, go through, set up the IP address, set up whatever. Can you templatize that? So the idea is, okay, so I set this up, maybe I have pods, right? And the pod delivers the same application just with a different IP address. There's a variable that changes, but it's the exact same configuration.
Yes.
Can I take that and say, hey, this thing I set up through all of this GUI process, I just want to go deploy that again, but here's the difference.
Correct. So I can take that configuration that I've built, I can then clone it to be redeployed, but change a variable or two if that's what I need to do.
Is there any way to do that programmatically
Yes.
rather than being inside of the GUI?
Yeah, like I said, this was just for the sake of example
Yep.
of showing you how it's done, but this is all, we have a full REST API, so 99.x% of our capabilities are also accessible through the API. I think the next example actually demonstrates some of what you're talking about,
Okay.
which we'll just kind of move on for the sake of time. So that was an example of what we can do kind of natively. We know a lot of customers are further along on their automation journeys, and they may have their own frameworks for doing orchestration automation. The customer may already have a way to get virtual disks and images into an ecosystem, and they may be using frameworks such as Ansible as an example. And so in the next demo, I'm going to show you how you can leverage the API to, on an existing load balancer instance, get an application template and a service published to that instance. In this example, my Kemp 360 Central happens to be running in VMware. My load balancer instance happens to be running in AWS, leveraging Ansible, leveraging application templates. I'm going to publish a new application service. And this will maybe answer some of your questions around the API as well. And here we go. So Ansible automation. Okay. So we're starting inside of Kemp 360 Central again. This time we're going to go into the repository where I have templates. And we'll just take a pause here for a second. As you mentioned, there was some point and click there. As we saw, there's dozens of settings that can be set. To help to simplify that process, what we've done is built out what we call application templates. This basically defines the best practices for how the load balancer should be configured for common application services that customers have. On our website, there's a section that you can go to, and we have dozens, I think at this point, over 100 different application templates. In this example, we see we have SharePoint, Exchange, Dell EMC, ECS, and so forth. But this basically removes the customer from needing to know what all those settings actually do. When I create a new VIP, I'm going to just take the practices that we've put in place to get that service up and running. And that's what we're going to show in this example here. I'm going to upload a new application template into Central. That's then going to stage it for use in deploying a new application service to that existing load balancer we have running in AWS. So I've picked up an Apache HTTP template. I'm going to upload it. I get a confirmation that it's there, and it's ready to go. So now that it's in the repository, I can push this out to the load balancer. Here we're going to log into that load balancer that we're using in the example, running in AWS. If we go to view modify services, we see at this point there's no virtual services. This isn't doing any load balancing yet. If we look inside of the application templates, there is no application template yet. So this hasn't been configured. It's kind of just a blank canvas. We're going to switch over to our Ansible workstation. From here, we're going to leverage a YAML file that we've created to trigger workflow. I'm going to preempt the question I imagine is coming. We don't have a Ansible module as of yet. We do have some code snippets that we've built out that are available, and we're regularly producing those. We have within the next few months on our roadmap to have a formally published module as well that'll be available inside of our Git repository. So stay tuned for that. By the way, anyone who's interested in that particular space of automation on these type of things, we welcome your input as we're building more community around this kind of space. So in this case, I'm just using the URI HTTP call commands that's available within inside of Ansible, and I'm leveraging that to call our REST API. Here in this file, a bunch of lines of code that define what the template is that I'm using that's inside of Central. It's defining where I'm publishing the service to, what's the IP address, and some other parameters around that. And moving along, we're going to run that YAML file. And here it's talking to Central. Through Central, it's telling it what to do with that load balancer instance that it has under management, which is to push the application template, create a VIP based on that application template. Now that that's done, if I go back to the load balancer, I'll see some things that are a little bit different. There's now the application template, that whole Apache HTTP suite. As you can see, there's different options. I can have it offloaded where I'm terminating SSL traffic. There's just plain HTTP. But that set of templates is there. If I go to my VIPs, I'll also now see a new virtual IP that's been set up. So a slightly different framework for still doing automation, right? In one, we're providing the kind of capabilities within our native set. And in the other, just leveraging our API, a customer is able to hook it into their existing orchestration framework. Any questions or anything that's not clear?
Are you able to take what you do in a GUI and export that in any type of format that, like your YAML output there, or your API calls? Is there any way to take what you do in a GUI and translate that into what the API looks like? It's kind of a template for you to use for future deployments.
Not fully yet, right? For some aspects, so I can take a backup configuration of what a device looks like. And we do have a set of tooling in our support tools that's exposed to customers where they can then go in, they can look at it, they can manipulate it. But in terms of taking the entire thing and turning it, let's say, into XML, it's not something that we have just yet, but it is something that we have on our roadmap as well.
So is the vision to use 360 as sort of the method for truth for the load balancers?
Correct. Right, and this is really just a building block as we move towards there. So that kind of covers what I would call day 2 or day 1 operations, right? It's the automation, it's the configuration in terms of getting things up and running. How do I make tasks more repeatable? Day 2 operations is when you start running into trouble, right? As you get to scale, you're bound to have issues, outages, and application challenges from time to time. This is really where vision comes into play, not the vision of our products, but the product Kemp 360 vision. The point of vision is basically, as I mentioned earlier, to preempt some of those issues that's likely to happen in an application ecosystem. A lightweight virtual machine agent gets deployed inside of the customer ecosystem. We start to absorb data points from the load balancer, from the application, as well as from the network. And based on a logic and rules that we've built, we're then able to surface preemptively when you may be having an application experience issue that's developing. I'll give you an example. I talked about email and messaging engineering as I've done in the past with Microsoft Exchange when people were still deploying it on premises more often than not. You could wind up with cases where you would have database failures, or you would have what's called split brain databases, where you have 2 copies of the database that both think they're in charge. Both of those problems were preventable. You just needed to know where to look. And it's the same case when it comes to many other applications. If only you could kind of piece things together across the ecosystem, look at the right logs, put it into context, there's many things that's repeatable. So here you see the kind of domains that Vision covers: application availability, traffic telemetry, security. So as an example, we're able to surface potential issues that may be starting to develop with your certificates, maybe the ciphers that you're supporting, if your certificate's up for expiry. And of course, there is a lot of load balancer-centric stuff that we do as well, but we've started to extend that to just core applications. So say you have an LDAP service that's being used for doing SSO and authentication. I can absorb information over WMI, over API, as well as over syslog to get insight about how that LDAP server is actually performing. I'll then give you context that based on what's happening there, you may start to have issues develop in this other application that's also relying on it. And then we surface that to the customer, right? That gets surfaced through common communication channels, could be SMS, email, Slack. It also creates a direct connection to Kemp support engineering. So the way that this works, as we mentioned, is the agent that goes on the customer site, but this connects to a SaaS cloud service that we have as well that we've built, and that provides a direct connection back to Kemp. So let's say there is a challenge that the customer has that they can't solve. Well, when the customer gets on the phone with our Kemp support engineers, we've already got insight about the issue. We may already have a solution for the customer. I would say we kind of talked about vision and so forth of these products. The vision of this is actual automated remediation for a number of flows and things as well. We've already done some POC work around that. The challenge I would say that exists there today is still comes down to customer comfort, right? Do you really actually trust me to tell you that there's a problem and then tell you that I did something about it, right? And there's still some on the fenceness, I would say, in general in the market, but that is the direction of where Vision's going. Today it's about giving you insight before issues happen. If they do happen, help you to know where to look and where not to look, right? So you're not wasting time going down rabbit holes, but the end game will be greater degrees of automation. We'll put this in the sake of an example to just help with kind of dimensioning this. Imagine a scenario. I've got an application on a load balancer. We've talked about load balancers. You've got that concept, and I've got some users connecting to it through a firewall. Now imagine that unbeknownst to the folks that are responsible for the load balancer and for the application, some new firewall rules get rolled out, which happens. And let's say those new firewall rules introduce some natting. This natting rule is now going to abstract the actual IP address of the users so that they all look like they're coming from a single IP address. May seem relatively innocuous, and it might be, but it might not be. Because if you think about how load balancers work, one common method you use for session stickiness and persistence is that you do it based on the individual and unique IP addresses of the users that are connecting. So if the firewall rule now changes things up, where everyone looks like they're coming from the same IP address, I'm going to start running into some issues. Maybe not day zero, but go back to the e-commerce scenario. Imagine that you fast forward through to an event, such as Cyber Thursday. If I'm persisting based on source IP, everyone looks like they're coming from the same IP address, well, I'm going to be sending all of those users to the same server. Under normal operations, that may be fine, but under the stress event, that could result in an outage. It could result in a real application experience problem. And so we address this, right? What Vision would do in this case is as soon as that happens, we would detect the fact that there has been some suboptimal application flow, right? We would give the insight to the customer. We're going to probably skip the demo for the sake of time, but happy to spend some time with you guys later. I know we've got some time planned later. But what would happen is that the customer would get a Slack event that would get surfaced, and that would give them some context. It would say, hey, I've noticed that your traffic load balancing isn't quite right. But by the way, nothing has actually changed on the load balancer. And that's actually the key part, right? The fact that the configuration change is not tied to something that's changed on the load balancer means that it's happened outside the load balancer. That app owner is now equipped to go talk to the networking team, talk to the firewall team, and get to mean time to innocence, right? They know that it's not their fault, but we've equipped them with some insight. And that's really the focus of Vision. It's to capture these types of data points, even if it's not specifically on the load balancer, but it's just about something that's going on adjacent to the load balancer in the application ecosystem, provide some context so that you know where to look and where not to look. The next steps of this, right, is to take that knowledge that we have and actually automate remediation of some of these common flows. Just one small anecdote on this, right? Over the years that we've been in business, we've collected a lot of knowledge about application problems through the thousands of support tickets that we've done. Vision is really a codification of that knowledge so that the customer doesn't necessarily have to get on the phone with support. This takes that support knowledge and puts it directly inside of the customer ecosystem. Like I said, we're going to skip this demo, but happy to kind of go through this a little bit more with you guys later.
So are you suggesting then that the Vision product can do like a diff between 2 points in time of the environment or the configuration?
Correct. I can give you some insight about here's the last configuration change that happened, as well as who did it, right? So you can start looking into things. So, and it's going to be in relevance too. If you change something that has nothing to do with the price of coffee, I'm not going to surface that. But if it's something that my logic seems to show is related, then I am going to highlight to you that this particular change happened. So in that example, if I had changed the scheduling method, how I distribute traffic, or I changed the persistence method, I'll say, oh, I noted that XYZ was changed on the load balancer itself. If I didn't, well, then I'm going to tell you that nothing's changed on the load balancer. You should go look elsewhere.
So you're saying that you can compare the differential on the load balancer itself, but you wouldn't necessarily, the load balancer doesn't have the insight, or Kemp Vision doesn't have the insight into a firewall rule got changed. It just knows something happened.
It doesn't have the full insights yet, right? In some cases it does. Like I said, we've extended some bespoke application-specific capabilities, not for all applications, but that is growing what we can detect outside of the load balancer ecosystem itself as well.
And is this predictive? Is it? You said you've collected a bunch of information about application issues that you've had over the years, or customers have talked to you about. So is this essentially based on sort of predetermined models of application behavior? You can do this predictive analytics, or are you actually also looking at, you know, just the vagaries of what's going on in a production environment?
There's models, of course, right? So we've got an expert system that's in place, and we've got rules and logic, but this is something that's continuing to grow. So we are evaluating about 200 new load balancer instances, primarily through our freemium model, every single day. Right? We're also pulling in new support tickets that's starting to develop, and all of that logic and information is continuing to be fed in this engine. Since it is an over-the-top SaaS service, we're able to update that somewhat real time for customers, so it is growing.
And does this apply to just a centralized appliance, or can you get this do Vision on all of your distributed, like per app?
You can do Vision distributed. I see I'm getting the time nod, so we're going to close off, but really want to talk to you more about this over a beer later on, Drew.
One more question if we can. So I day two, the problem remediation and visibility is good, but sometimes there's just operational considerations as well. Like, what if I want to change the password on all of my boxes, right? So when you're talking about a distributed model, where now instead of 2 central boxes, you're recommending a per application or possibly a per pod horizontally scaled model, I need tools to be able to do that across the board. Is that something I can do from central, or is that something I'm going to have to write myself from an API call or something like that?
There's 2 approaches to that. I don't think we're going to have time to get into that, but grab me later. Let's talk about it, because there's 2, I would say, fundamental philosophical approaches you could take when you're trying to do that, and your environmental kind of approach will impact that. But let's get some time to talk about that later for sure. So just wrapping up, right? Per app load balancing. This is the future, right? We're at the spearhead of this. As we talked about, there's both commercial aspects, there's technical feasibility to make this possible, and we've sought to address those with our Kemp 360 framework. One just last point, from a customer perspective, I mentioned ASOS earlier. They're one of our customers you can check out on our website, where they've actually implemented these capabilities and framework for addressing their requirements of this very kind of spiky usage that they had specifically related to kind of commercial events. And this is kind of the framework that we're seeing, and we expect to see this take hold even more as DevOps and cloud and virtualization take hold. So thanks a lot for your time today. Thanks for the great questions, and I look forward to engaging with you folks a little bit later on as well.